Hello, welcome to Maitri Vidya YouTube channel. So in this video, we will be discussing position of a line with respect to a circle. So from the diagram, I have a circle here and I have a line here. So let me select this line. Okay. So now the line is neither intersecting nor touching the circle. So if I move the line without changing its direction, so I'm moving the line. So at this position, it is touching the circle at only one point. So this is the condition that the line is touching the circle, and if I move further, the line will be intersecting the circle at 2 points. So if I move further and further and further and further, still it is intersecting, still it is intersecting. So if I move further and further, so again at this point it is touching the circle again, and it is moving outside the circle now. So this position is line is neither intersecting nor touching the circle. This position is line is touching the circle. This position is line is intersecting the circle. Okay. So we are going to discuss those three conditions. So with the help of equation of a circle and equation of a given straight line. So let us assume that the circle equation is x square plus y square plus 2gx plus 2fy plus c is equal to 0. So from this circle equation, I can find the center. Center coordinates will be minus z comma minus f, and the radius value is under root of g square plus f square minus c. So now assume that the given line equation, so the given line equation is ax plus by plus c is equal to 0. So that is the general equation for a line. So now I have this line equation, I have this circle equation. From the circle, I have center and radius. So now what I have to do is, from the center of the circle, I have to find the foot of perpendicular. Okay. So the distance, or otherwise I can say that the distance between center and the line. Okay. So that will be the distance between foot of perpendicular of the center on this line. So the foot of perpendicular will be at this place. So the distance between center, okay, let me denote the center as C, okay, the foot of perpendicular as P, okay. So the distance between CP is nothing but distance between the center and the given line, okay. So we have the distance formula between a point and line. So the distance formula between a point and line, so that is denoted as D, is equal to mod of A x1 plus b y1 plus c whole divided by under root a square plus b square. So the x1 y1 values here, the x1 y1 values here will be uh, the point from which we are finding the distance between the point and line, okay, the coordinates of those points. So that means the x1 y1 values will be here minus g minus f. Okay, substitute in the place of x1 minus g value. So in the place of y1, we have to substitute minus f. So we can have the a, b, c values from the line equation. Okay, so the distance is well known here, and the radius is under root g square plus f square minus c. So this can be found from the circle equation. So now if you observe, the highlighted part here is the radius. So the distance is cp distance. So which one is greater? So the CP distance D is greater here, okay, than the radius of the circle, okay. So in this case, I can say that radius of the circle is lesser than the distance between center and the line, okay. So whenever we get this condition, So what we can say, line is neither touching, neither touching nor intersecting. Okay. So I told you that one more condition is touching condition. So I have a diagram here. In this case, I can say that, so the distance between the center and the line, that is D, should be equal to the radius of the circle. So we can sense that through the diagram, that highlighted part is radius, and the distance between the center and the line is that thin line. Okay, so that is distance D. So in this case, the distance value D value and the R value, radius of the circle, we are going to get the same. So in this condition, we can say that line is touching the circle. Line is touching the circle. So now what we have to do is, we have to move the this line further. Okay, so it will be intersecting. Okay, so now the distance, the thin line part, that is the distance between center and the given line. So it is lesser than the radius of the circle, that is the highlighted part here. So the radius will be greater. Radius will be greater than the distance. Okay, so if I get this condition, so I can say that line is intersecting the circle. So that's it for this video, and I hope you have understood concept of position of a line with respect to a circle. So thank you very much.